Okay, welcome to the matrix of your Cambridge exams. Right now, when you open up a past paper, you're probably seeing an intimidating wall of text, confusing command words, and just impossible data tables, right? But top-tier students, they don't see the paper. They see the patterns. They literally see the code behind every single question. Today, we're diving deep into this explainer where we take you directly into the examiner's mindset. We are focusing specifically on the Cambridge Information Technology syllabus, code 9626, and we are cracking the code on section 8.1, referencing. Now, I want you to imagine two students walking into this exact exam. Let's call them Alex and Sam. When Alex sees a complex spreadsheet referencing question, Alex's strategy is to just overload the page with raw facts, writing down every single thing they know about spreadsheets, but offering absolutely zero critical analysis, just a massive brain dump. On the other side of the room, we've got Sam. Sam is racing against the clock, rushing through the command words, completely missing the specific requirements of the prompt, and dropping super easy method marks left and right. If you looked at their papers, you'd see flawed answers, just bleeding with red pen marks from the examiner. Why does this happen? Because they don't understand the underlying matrix of the exam. They don't have a system. But by the end of this session, you absolutely will.
So let's start with this absolutely massive statistic. Absolute, relative, mixed referencing, and named ranges, they account for approximately 15% of your total marks in Paper 2. Stop and think about that for a second. 15%. That is literally the difference between an A and a C or an A star and an A. That single chunk of marks is entirely dependent on your mastery of just a few core concepts in spreadsheet mechanics. When examiners sit down to grade your paper, they aren't just looking for candidates who know what a dollar sign does in a formula. Anybody can memorize that. They are actively hunting for students who understand the deep conceptual reasons behind why you use it in a specific business scenario. If you're leaving these marks on the table because you're rushing like Sam or just memorizing basic definitions like Alex, you are doing yourself a massive disservice. The stakes here are incredibly high. But here's the beautiful part. This 15% is highly predictable. Once you know the system, once you can spot the patterns in the data, these become guaranteed marks in the bank.
Now, to actually succeed here requires a massive shift in how you think. You see, the academic benchmarks strictly prioritize analytical depth and connected reasoning over superficial breadth. Let's look back at our student Alex for a second. Alex thinks that by listing out every single feature of a spreadsheet software, they're proving how smart they are. That is superficial breadth. The examiner reads that and immediately knows Alex is just guessing, hoping something sticks. Cambridge Information Technology candidates must demonstrate mastery of fundamental principles, not just software trivia. The syllabus is super clear on this. Top-performing students exhibit connected conceptual understanding that is fully transferable to completely unfamiliar contexts. This means when the exam throws a bizarre, highly complex real-world business scenario at you, something you have literally never seen before, you don't panic. You rely on analytical depth. You logically and structurally reason your way through the data. You don't just state what referencing is, you analyze exactly why a specific type of referencing is the only logical choice for that exact grid of data.
To secure those top scores, you must demonstrate mastery across 3 distinct cognitive domains: knowledge and understanding, application to unfamiliar contexts, and critical analysis. And this is where we reveal our ultimate strategy to conquer command words. We call it the PEAL framework. Point, evidence, explanation, link. To satisfy these 3 cognitive domains, you make your point to show knowledge. You provide evidence extracted directly from the exam-specific data table to show application. Then, you give an explanation of how the referencing mechanically works to show critical analysis. And finally, you link it back to the question's core objective. This is the exact, step-by-step strategy used by top students to boost grades consistently. Before we continue, subscribe to our YouTube channel Ace the Exams at Ace the Exams IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, so think about the command words tied to these domains. When a question says explain, it is targeting that third domain, critical analysis. When it says apply, it wants you to take your knowledge and map it onto the unfamiliar context using the evidence step of PEAL. It's a complete game changer once you see it.
Let's rapidly break down our toolkit, starting with absolute referencing. This is a core principle you must apply when executing your analytical framework. In the matrix of a spreadsheet, absolute referencing is your anchor. It's the use of dollar signs, like $A, $1, to lock a specific cell reference so that it absolutely never changes no matter where you copy or drag that formula. But remember, the examiners don't just want the textbook definition. Let's apply our PL framework right now. Your point. Absolute referencing locks the target cell. Simple. For your evidence, imagine a tax calculation table in your exam paper where tax rate is isolated in a specific cell, say D4. Your explanation. By using those dollar signs to lock the reference as $D, $4, the formula guarantees that as it replicates down the employee list, it consistently multiplies by that exact tax rate without shifting down to empty cells below it. Your link. Therefore, absolute referencing is the only logical, structured method to ensure accurate payroll processing across the entire dataset without manual input errors. Boom. Do you see the difference there? We didn't just define it, we analyzed its critical function in a highly structured way.
Next up in the toolkit is relative referencing. This requires you to truly understand the relationships between data points and transfer that knowledge to new scenarios. Relative referencing is basically the default state of the spreadsheet universe. It's fluid, it moves. If you copy a formula one cell down, the reference moves one cell down. Now let's look at how our rushing student Sam might answer a question on this. Sam might quickly scribble, relative referencing changes when you copy it, so it's faster. Ouch, that is a classic low-tier answer. It completely misses the conceptual understanding. A top-performing student using our framework writes, relative referencing dynamically adjusts based on its spatial relationship to the formula's location. When calculating the total cost for 50 distinct inventory items, relative referencing allows a single formula to be replicated down the column, instantly mapping to the corresponding quantity and price for each specific item row, thereby saving time and eliminating manual data entry. You are demonstrating to the examiner that you understand the spatial relationship between the cells, not just the mechanical action of dragging a mouse down a screen.
Then we have mix referencing. This is an essential tool for when you need to solve systematically and check for reasonableness in your data interpretation. Look, this is where top-tier candidates completely separate themselves from the rest of the pack in the 9626 exam. Mix referencing means locking either the row or the column, but not both. Think $A1 or $A$1. It is a hybrid approach used for multi-dimensional data analysis. Think of creating a massive multiplication table or a two-way sensitivity analysis for a complex business model. When an examiner puts a mixed referencing question on the paper, they are testing your highest level of cognitive analysis. They want to see if you can deconstruct a multi-layered problem, solve it systematically, and check for reasonableness. If you accidentally lock the row when you should have locked the column, your output data will immediately look completely unreasonable. You must explain to the examiner exactly why only one dimension of the reference is anchored, while the other remains fluid to accommodate the specific grid layout provided in the question. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Finally, we have named cells and ranges. These ensure that your presentation follows strict conventions, allowing you to draw clear, evidence-based conclusions. We are moving into the transformation phase of our strategy right now. I want you to imagine looking at a formula that says equals A4 times $C$9 minus F12. It's just a mess of alphanumeric code, right? It takes genuine effort to decode. Now imagine a formula that says equals gross_pay times tax_rate minus deductions. That is the absolute power of named cells and ranges. Cambridge explicitly assesses your ability to follow strict conventions, use correct terminology, and provide clear annotation. Naming a range doesn't change the mathematical output at all, but it fundamentally transforms the readability and structural integrity of your model. When you use named ranges, you're basically winking at the examiner and saying, I am a professional. I build systems that are transparent and easily auditable by third parties. If you want to transform your red marks into green check marks like we talked about earlier, start applying named ranges to your evidence when you structure your Peel exam answers.
And this brilliantly illustrates your exact procedural framework for the exam. Deconstruct, extract, select, execute, and present. This is your ultimate success blueprint, completely applicable to every paper you'll face. Step 1. Deconstruct the command word. Is it asking you to evaluate or just state? That tells you how deep to go. Step 2. Extract only the relevant data from the messy scenario they give you. Ignore the noise. Step 3. Select your analytical framework. Ask yourself, are we using absolute, relative, or mixed referencing here? Step 4. Execute the formula with perfect, clear notation. Step 5. Present it using correct terminology and named ranges. If you follow these 5 steps systematically, you are building a completely foolproof strategy to tackle literally any referencing question they throw your way. It takes the guesswork out of the exam and turns it into a simple, step-by-step algorithm.
Now, As you follow those steps, you absolutely must stick to these strict conventions, because extracting from texts and tables requires flawless presentation and annotation. Let's do a quick mental workshop here. Imagine a 60-second timer ticking down. You're scanning a complex data chart. The examiners are ruthless about presentation here. You can have the most brilliant, genius-level conceptual understanding of mixed referencing in the entire world, but if your presentation is sloppy, you lose marks. It's that simple. Proper headings mean your data tables clearly label exactly what is being calculated. Correct terminology means you write replicate instead of drag and absolute reference instead of that $ thingy. Appropriate formats mean formatting currency as currency and percentages as percentages to the exact number of decimal places specified in the prompt. Clear annotation means using comments or named ranges to explain your logic. Take a mental pause right now. Imagine rewriting Sam's messy, rushed answer into a beautifully polished masterpiece using the Peel framework and these strict conventions. That is how you build a 100% mark potential.
Top-scoring candidates don't just calculate. They demonstrate evaluative thinking by questioning assumptions and identifying limitations that might actually affect their conclusions. When you face a massively complex spreadsheet detailing, say, regional sales data across 5 years, you need to do an immediate mental data scan. Ask yourself, what is the core trend here? Are the sales formulas using absolute or relative referencing to calculate the year-over-year growth? If you just blindly trust the spreadsheet without checking the code, you aren't doing critical analysis. You need to question the assumptions made in the model itself. What if the tax rate used as an absolute reference changes halfway through the fiscal year? What are the alternative interpretations of this data? When Cambridge asks you to evaluate a spreadsheet model, they want you to identify these exact limitations. You have to justify your decisions with hard, undeniable evidence extracted straight from the text.
Let's move to the pitfalls you absolutely must avoid. Examiners explicitly warn against confusing cause and effect, ignoring formats, and giving generic answers that ignore the specific context. Okay, workshop time again. Challenge 2, find the flaw. I'm going to read a sample paragraph, and I want you to spot the sentence that loses marks. Listen closely. Absolute referencing is used to lock the cell, so the formula is right. The spreadsheet looks good and calculates the numbers quickly. Did you catch it? The flaw is mistake number 3. It is completely generic and totally ignores the context. The principal examiner reports highlight this exact mistake year after year. Students memorize a textbook definition and just paste it onto the page without ever mentioning the specific business, the specific cells, or the specific data provided in the paper. They also confuse cause and effect, thinking that applying a named range somehow magically calculates the math rather than just improving human readability. And as we just discussed, forgetting to check your final currency formatting will cost you easy, totally avoidable marks every single time.
This brings us to an incredible insider secret straight from the examiner alerts. Always show your clear working, because method marks can absolutely save your grade. In IT 9626, problem solving is a process. Deconstruct, solve, evaluate. As you listen to this, internalize this concept. Imagine a 30-second speed writing challenge where you just need to get your Peel paragraph down. If you type the wrong final number into a cell because your finger slipped and hit a wrong key on your calculator, but your written evidence shows you correctly identified the need for a mixed reference, correctly structured the formula layout, and correctly named the ranges, the examiner will still award you method marks. The process is prioritized over the raw output. If you just write down a final number and it's wrong, you get a big fat 0. Showing your code, showing your patterns, showing your step-by-step working, that is your ultimate safety net in the exam room. The process is just as important as the final answer, so you must systematically identify key elements, execute with clear working, and verify your results. This is it, the final system. The 3 rules that guarantee top marks. Rule 1. Command word decoding. You must know exactly what cognitive domain you are being tested on before you write a single word. Rule 2. Peel framework application. Never, ever write a paragraph without a clear point, evidence, explanation, and link. Rule 3. The time management matrix. Don't rush blindly like Sam, and don't overwrite unnecessary trivia like Alex. Systematically process the question. Identify the given information. Break it into logical, bite-sized steps. Check your output for reasonableness. Make justified recommendations based entirely on your analysis. When you combine this method mark strategy with strict exam conventions, your mark potential progress bar shoots straight to 100%. You are no longer just taking an exam. You are executing a proven, calculated algorithm for success. To ensure you never forget this 15% secret, I challenge you to create your own mnemonic using the first letters of our court terms to lock this into your memory for exam day. A-R-M-N. Absolute, relative, mixed, named. Maybe it's always read my notes or all referencing must name. Find a phrase that sticks in your brain and write it at the top of your paper when you sit down.
Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCS and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.